All right, you guys, I know we already covered this in class a million years ago, but I figured it was worth having at least in our notes and stuff in case you needed to look back at any of these definitions. But here we are in chapter 10, parallel and perpendicular lines. Just to remind you guys, parallel means for us in the past, it has meant that two lines specifically, will never cross. We're going to get more specific with those definitions in here. Perpendicular, again, means intersecting in opposition to the parallel, which never intersects, but perpendicular means that they intersect specifically at 90 degrees. So in your notes, if you haven't already, just make sure that you've attached 90 degrees somewhere near this perpendicular. We're going to start associating those two together. All right, so what we're going to start with here in chapter 10, again, we've done this already in class, but pairs of lines and angles. There are specific groups and pairs of things that have special properties, and so we're going to talk about those in this chapter particularly. But a little background information, some definitions that you should already be familiar with, again, already in the notes, but let's go ahead and go through it anyway. First one, parallel lines, two lines that will never intersect. That's what we've dealt with in the past. You will see this symbol, two sideways dash marks kind of looking like parallel lines themselves. And the addition here is that we're going to add in this fact that they have to be coplanar. Again, the reason that we include this as part of our definition is because now we're dealing three-dimensionally. And when we deal with three-dimensionally, it's possible for two lines to never intersect that aren't on the same plane, and they're definitely not parallel. So for parallel lines, they do have to be on the same plane, and they never intersect. Skew lines is the other end of that spectrum, two lines that will never intersect but are not coplanar. Okay, so three-dimensionally speaking, here in this diagram, that would be like line K and line M right here, never intersect, never will intersect, but because they're not on the same plane, that does not mean that they're parallel. Okay, so we call those skew. Parallel planes, similar to parallel lines, being two planes that will never intersect, much like plane T and plane U shown here in the diagram. Kind of think of it like if this was our classroom, that'd be like the ceiling and that's the floor. Important because that means that at no point will anything on this plane touch anything on that plane. So that's what parallel will mean for us. All right, so let's move on. At any point, feel free to pause this video and pick up the stuff that you need specifically, or spend more time, rewind, whatever you want to do. All right, so this key term right here, transversal, this is one that's going to pop up a lot in this chapter, as I pointed out before in the classroom. It's going to be a line that intersects two or more coplanar lines at different points. It's a very fancy way of saying we're going to get situations like this. Okay, pretty much everywhere throughout this chapter, you're going to get these sorts of situations. You're going to have two or more lines going generally in the same direction, like these two. Okay, we're going to deal with them being parallel in the next section. But we have multiple lines going in the same direction. The transversal is the one that crosses them. Okay, so this line right here is what we call a transversal. Right, and you can think of it like it's what crosses the H. Right, so this is like an H on its side, and the transversal is what crosses it right here. And the important thing to understand here with the transversal, or any intersection for that matter, where two lines intersect, you get a group of four angles. So if I'm crossing two lines, I have two groups of four. In this case, I have 8 angles that are made. And what these four important definitions deal with are groups and pairings of those angles that are made between those two groups. Because we have a couple of properties that I asked you guys to have in your margin in our classroom notes that deal with the single intersection. The first is vertical angles. Vertical angles, like angle 2 and angle 3, are vertical angles. Those angles will always be congruent. So I can figure out what angle 2 and angle 3 are because of vertical angles. Angle 1 and angle 4 are vertical angles, but that only happens in one intersection. Corresponding angles, what we're going to deal with specifically in this section, in this chapter, deal with now crossing over between two groups of intersections. And so corresponding angles for us mean same position. So angle 6 and angle 2 are same position angles. Upper right, corresponding angles. Now, there are other options here for corresponding angles. Angle 1, for instance, is corresponding with angle 5. Angle 3 is with angle 7. Angle 4 with angle 8. And each of those would be considered corresponding angles. Alternate interior. Alternate interior means diagonal inside. By diagonal, I mean going across or diagonal across the transversal. So there's our transversal. There are two clusters of angles. Alternate or diagonal, opposite, whatever you want to use there. Interior or inside. Inside refers to the fact that we're only going to be dealing with the inside, the sandwich part, inside the sandwich part, these two clusters of angles. So 4 and 5 are what we would call alternate interior. 3 and 6 are also alternate and interior. So you do have options again. All right, and our last two here. Alternate exterior or diagonal outside for exterior. Now I'm dealing only on the outside of these clusters. So again, diagonal or alternate means across this transversal. So 1 and 8 are both outside and diagonal across the transversal. 2 and 7 are also diagonal across the transversal. Okay, and finally, consecutive interior. Same side, inside. Literally, consecutive means in a row. So for us, that just means consecutive on the same side. So 4 and 6 are consecutive interior angles. 3 and 5 are also consecutive interior angles. In each of these cases, I just highlighted one pair so we could see one pair of what would be considered corresponding alternate interior, alternate exterior, and finally consecutive interior. But there are other options. All right, so what the important thing to understand here, the main punchline to understand here is that these four definitions right here are going to pop up a lot. And so far in this section, section 1, we're only dealing with the position. Okay, there's no other property involved with this yet, but we will talk about this in section 2, other than saying what is same position angles, what are consecutive interior angles, what are alternate exterior, alternate interior. Okay, so these just have to do with positions. Right? As always, if you have questions, feel free to email.